Hey, hello. I think we're going to go ahead and get started. Slides are up. Yeah, so this is my first time in front of like people I can actually see. I'm used to doing like live streams and like you don't know if people are there or not. But now I can see you, and then apparently there are people out on the internet watching us. What a concept. So welcome to shortening the time between make it work and make it fast. If you didn't catch the pun, I can do that again. Shortening the time between make it work and make it fast.
Oh, I get it the second.
Yeah, see? That's how you know it's a good joke, because they get it on the second time. But yeah, so that was our slides. But first off, introductions. I like to start, I gotta stop looking away from my mic. I like to start with, this is Atticus. He is my 7-month-old tricolor Pembroke Welsh Corgi, which is a mouthful. And you can say, like it's a dog. Oh, wait, go ahead. Thank you. And then that leads you to me. I am Atticus's human. I'm Aydrian Howard. I'm a developer advocate at Cockroach Labs. My Twitter, Instagram, and Twitch handle is It's Aydrian, which is a little more awkward than I thought it would be to tell people. They're like, what's your Twitter handle? And I said, it's Aydrian. And they start typing in Aydrian. I'm like, no. It's Aydrian. And now you might not ever forget that. So I hope to see you on Twitch. So today we're going to take a look at this quote by Beck. If you work in software, you probably heard it before. Is everybody familiar with this kind of mantra? Make it work, make it right, make it fast. I have worked in a couple startups in the last few years, and that was really kind of what it is. Let's make it work, let's make it right, let's make it fast. Not dwell on things, let's keep going, make sure things work. So we're going to go over that first, so we can kind of talk about each individual part. So we got make it work. What we're trying to do here is make sure that the problem is solvable. You are going to have little to no tests. You might have poor performance. You have cruft code. You're really going towards that happy path solution. And then it's important to know these things, like if it's solvable, because then you can get it out there. You can see if there's product market fit. If you're part of a startup, like that's really important, because eventually you're going to want more money. And so having something out there that's working is going to help with that a lot. But normally, you don't want to push this code to production. It should be avoided. But as like a developer advocate, I feel like this is where I live, and I push everything to production. I also live dangerously and test in production. So like how many of you have been part of a deployment of a product that has just like gotten this far? Anybody? Yeah. What other, like, I want this to be like interactive. So like, have you done anything else that's like a little shameful? And just remember, this is a safe place. It's just us in this room and anybody else out on the internet. Have you done anything else in addition to these things that like, yeah, you're not so proud of, but like things to get things out there? Yeah. What? Oh, you have, okay. Just looking for examples, but we can move on. So that's make it work. It's the important one, I think, but not more important than the other ones. So the next part is make it right. So this is the point where you know that things are working. There might be product market fit. There might be everything. So we're going to move on to the next phase, and that's the make it right phase. This is where we're going to go back and we're going to include our tests, the things that we never really do. At one point, I was reading about test-driven development. Does anybody do that? Oh, okay. I don't know, like, that's great. I love that. Like, I love being able to code, and then all of a sudden, all the lights turn green, and you're like, things work, but I can't get my head around that. So, like, I write the test afterwards, and it's probably not the right way to do it. But good for you. Like, I'm going to have to go back to that. Yeah. So including tests, making sure you have proper syntax and naming conventions. Those are important. Removing any hard-coded data. I know that like when you're just trying to get something out there, like you working towards that happy path, like let's just make sure that this goes through. This might not be the data that your customer is going to put in, but we're going to make it work. And so make sure you make sure you get rid of any of that data, and then start thinking about edge cases. So we're no longer pushing towards the happy path. Thinking about how can a user stray, and then how can we get them back on? And at this point, the code should be bulletproof, missing a word, bulletproof and production ready, just like my favorite LaRue song, "This time, baby, I'll deploy bulletproof." No? See, I was gonna have like sound effects queued up, but that's difficult. Okay, so that was make it right. We just did make it work. And so the last one, this is make it fast. And so it's not just about making code run faster, but you want to ask yourself these questions. How do I make it more testable? How do I make it more extensible? How can I make the code more valuable to the user? And these days, along with make it fast, we have to think about making it scale. So a lot of times, whenever you hear this these days, it's make it work, make it right, make it scale. Because a lot of things can happen. And we'll go over that in a minute. So you have like the startup gnomes, and I feel like this is like the places that I've been where the startup gnomes come in and they're like, we're gonna make it work and we're gonna deploy. And then phase 2. And then phase 3, we profit. But like that big question mark, we need to go back and do these things. And one of my favorite memes, well, at least like the meme template. So it's like, our app works and I deployed it. And it's like, you're gonna make it scale next, right? And of course, like Anakin, I think the only thing that's actor's known for is like this brooding face. Like you get nothing, and she's like, you're gonna make it scale, right? Okay. And then I feel like that's kind of where it stops a lot of times. Or like once you get to a point where you have enough customers, it's enough of a priority, and then you finally go back and you do this. Until one day, well, that got moved down a little bit. Thank you, resolution. Until one day you wake up and this is what you see on the orange site. It is the new application you just deployed, is what it said. It's at the top of Hacker News. Has this happened to anybody? Has anybody gotten to the top of Hacker News? Yeah, I don't know. Is it possible? Can you do it? So this happens. Just imagine this happening to anything that you've deployed. Now, in the marketing department, they are going nuts. This is what they live for. This is what they want. Like, yeah, we made it. People know who we are. And they're celebrating, there's champagne, there's everything. But meanwhile, engineers are like, oh no, it's probably fine. No, it's fine. Nothing can go, what could go wrong? Something could go wrong. But like, did it crash? We were just on this big orange website that everybody looks at, and we were inundated by traffic and users. Did it crash? Like, what could have gone wrong? Like, imagine this was your application. What are things that would just worry you about that day? Anybody? Did it scale? Did the database handle the load? Did my code operations go? Did they get a 404? Did they get a 500? Did we get leaked? Did the hackers find us? Yeah, so like that's scary, and I know a lot of places that I have, like, it's the goal. The goal is to be at the top of Hacker News, but like, are we ready for that? And so is your code ready for that? It's a good question. So what that led me to is the work that I've been doing with serverless functions, building them in JavaScript, like I do, because for the last, I don't know, decade plus, let's not focus on age. I've been writing them in JavaScript, and everybody knows how they work. There's like a cold start, like the first time they're hit, they warm up, and then they run pretty fast. But can we improve that anywhere? And what I've been doing, well, I guess I'm getting ahead of myself. So we're gonna explore building on serverless. Um, and I guess we should start with WTF is serverless anyway. And I borrowed this from one of my colleagues' blog posts, and I'll have the link at the end in a nice little resource sheet, so if you want to like take a little snapshot, you can. But serverless is the next logical evolution of the cloud computing paradigm. Because it enables even more efficient use of limited resources, time, money, and developer brainpower. So I wanted to kind of key in on these 4 fundamental principles for like what is serverless. And if you're interested, you can go and read the rest of the blog post, which is, of course, much longer than just one slide. So we're going to talk like the hands-off server service. I started as kind of a front-end developer. Yes, I was made fun of in college because the web was a fad, and all of my friends who went off to join gaming companies are now making less than me. It's fine. I didn't want to have to deal with like spinning up a service. I would get to the point where I can do Node.js. Node.js came along, building with Express.js, and then it's like, well, what do I do with this application? How do I run it on anything other than localhost? So that was like beyond me. There was no Kubernetes. Eventually, Heroku came along, and I could like spin up that. But like, what's a dyno anyway? Automated elastic scale. I don't have to worry about what happens whenever traffic increases because it's going to take care of that for me. I love that. Again, I'm a developer. I want to focus on the code, not worrying about the infrastructure. Consumption-based billing, only pay for what you're using. Whenever I was deploying to Heroku, I had to pay for the dyno. Whether I was using the app or not, I had to pay for that dyno. Most of the apps that I build now, they're part of my streaming, and so like I stream on Fridays. Like, why should I have to pay for usage on the other 6 days? And then built-in resilience and fault tolerance. So this is what we're talking about when we talk about serverless. So we've got functions as a service, which is part of serverless. So this is what's really nice because it's written using known languages, JavaScript, Python, etc. Does anybody use, and we're not talking about compiled languages yet, but does anybody use languages other than Python and JavaScript for serverless functions? Okay. It's the easiest way to get started, especially if you're using something like Netlify, which helps you with deploying them. They're just lambdas underneath. It allows you to deploy smaller units of code. So when I was writing things in Node and Express, like I would build out the whole CRUD system, CRUD routes, all of that, and deploy it. And for this, I can just target individual pieces. And I think that's gonna be important later on because they're nice and isolated, so you can replace them one by one as you need them, as long as you follow your API. But then we have to talk about cold starts. So the thing about not paying for things when you're not using them is they have to be spun down. You have to actually stop using them. So whenever somebody hits it again, it has to start up, and that's a cost. So it could take a matter of milliseconds, it could take seconds, it just depends. And then for those of you who haven't seen, I just put a nice little example of a hello world, so just to show what it looks like writing it in JavaScript. So you have the handler function, it can be async. You're given an event that's gonna have your query string parameters, your body, your headers, all of that. And then there's a context with some extra stuff if you're doing like authentication and whatnot. But then all you have to do is return this nice JSON object that has like a status code, 200 OK, and then anything you wanna put in the body. So the body is a string, so if you wanna pass JSON back, just make sure you stringify that. But it's really easy for a lot of people to get up and going. If you're deploying on Netlify, you just need to create a folder, Netlify/functions, and then put this function in there, and boom, you have a function. Then I want to mention Serverless Database. This is taken from a really cool video, which I have put on the resources page as well, but it's a traditional database features combined with the value and flexibility of serverless architecture. So it abstracts away any database complexity with an API in the cloud. I love this. Like, there's database as a service out there, but you still are beholden to like the clients, the drivers. So if you're using something with MySQL, you have to pick out your favorite MySQL client. If you're doing something with Postgres, favorite Postgres client. If you're using MongoDB, you Well, you have to use their client, or their driver, that's what you have. But you still have to deal with connection pooling, and it just doesn't quite feel right, like on a serverless level, setting up a connection pool to make one thing and then close it down. So serverless databases are moving towards that, like API in the cloud. Like, how cool would it be to be able to send a SQL query to an endpoint? I would love that for SQL. Like, I know a lot of people are abstracting things out into GraphQL, and you can do that as well. So these are the key elements of the serverless database that we're trying to hit. Automated elastic scale. Again, same thing like with the serverless functions. If you get a huge load, it will expand for the need and then bring it back down. Native resiliency, simplicity and familiarity, consumption-based billing. Again, let's only pay for what we're using. I love that because I try to live inside the free tier a lot. But like if you get outside of that, which is what everybody eventually wants, like you end up with a bill for like $5, and I can handle that. Or I can bill it to somebody, pass that on. ACID transactions and speed. And if you're interested in serverless databases, I might know one, just right here, just this right here, that launched today. So you can come find me at the Cockroach DB booth after this, and we're happy to talk to you about anything. All right, are we done with the? Okay, we're done with our intro to serverless. It was quick, but hopefully it was good. So let's talk about improving the performance of serverless. We talked about the function, the cold start. There's execution time and all of that. And we're using languages that are interpreted. We're using JavaScript, we're using Python. And so to run those functions, all of your code has to be interpreted. So that adds on to that cold start time whenever you start things back up. So how do we get around that? Well, we can use compiled serverless functions. Written in compiled languages such as Rust and Go. I believe you can also write them in C#. I think that's Azure Functions allows you to do that. And then what happens is at deploy time, all the code gets compiled into a binary that is then able to be run. So instead of interpreting all the code and then starting it up, there's a binary where everything has been linked and optimized and everything during deploy time. So you don't have to spend that time every time the function warms up. So that gives you faster start and execution times. And then the thing that's really cool is because of the way you write your serverless functions, you can easily swap those out for existing functions. So as long as you keep your API the same, the user's never going to know if you're running a JavaScript function or you're running a Rust function. But hopefully, it will be faster. And so here is an example of using Hello World and an AWS Lambda using Rust. So there's a great crate out there called lambda_runtime. And then what you do is every Rust function that is a binary has a main function. And so in that, you're setting up your handler function, which we have down here, which takes in a value and a context, which I'm just not using because it's Hello World. And then it runs that. And so whenever during deploy time, all of that gets compiled into a little binary, copied into the file, and it's just easier to start up. And I did a demo, so I created a little demo project, which is going to be fun. It's going to use your phone. I think there's like some disclaimer around standard texting rates will apply. But I hooked this up using Twilio. And so we're going to run a little demo, and I'm going to put the number up, and we're going to have you text your GitHub username to this number. And I want you to think about or keep in mind how long it takes us to respond. Because the first thing that we're doing is using the JavaScript functions. So here we go. So feel free to text your GitHub username to this number, which I think is in New Jersey. It doesn't really matter, as long as it's not in a different country. So text that, and then what I'm going to do is I'm going to immediately start a build to push over the Rust functions. And hopefully it will get done because we're compiling all this. It takes about 8 minutes to deploy. So how are we doing on time? We're doing okay. Okay, great. All right, so I'm going to really quickly go over, and I'm going to push this commit. Cool, and so that's up, and then eventually we're going to have a little deploy here. So we're building. All right. Has anybody gotten their response yet? Excellent, excellent, excellent. Is it cool? Was that delightful? Yeah. Okay, let's talk about it. You should get a response similar to this. I can see it here too, and right here. I don't know why I'm looking up there. So this is a simple Twilio webhook, and I have it generating an image because I was trying to find something that was a big enough workload to kind of show the value in switching between functions. And so now we've got a tale of two functions. This whole demo uses two serverless functions. The first one is the Twilio webhook receiver. So we have, I don't know, I'm going to call her Brittany. She's got a ponytail. Seems like a Brittany to me. So Brittany sends a text to the Twilio phone number. Twilio will send a post to my netlify function. So my netlify function is just a Lambda function deployed by netlify. All of the billing and everything is handled by netlify. And there's a pretty generous free tier, so I can play a lot with this. The netlify function is going to do really two things. It's going to verify the signature, which is it's going to take the signature that is passed over in the header. We're going to do some computations on the body, make sure that those match, so that way we know that this comes from Twilio. Has anybody written any webhooks? Anything that accepts webhooks? Do you check signature verification? Good, good, good. I love webhooks. I discovered them whenever I went to work for SparkPost because that was the way we delivered the information about emails out to people. Like we didn't have a pull service where you can say, give me all these metrics. We push them to you because that's the way we were trying to push people. And I'm really big about making sure like it's coming from where it is. So like no hackers are going to come in here and like spoof my Twilio demo webhook, but it's good practice. And so I like to make sure I do it. And then after that's done, we're going to move on to just returning TWIML. So if you're familiar with Twilio, they have XML, like you do these days, for the response. And this is what it looks like. I'm not using this exact same text, but you have a response. We're saying return a message. The body is whatever text it's going to be. So in this demo, it's the JavaScript function response. And then we also have a media tag where we can give it a URL to the image. And that's going to insert that into the response. And so that's what you got. This is not hardly anything of the demo. This is just receiving the message and then sending a response. Everything is done inside of this media tag because the URL that we are sending is actually to another webhook that generates the image. And so that is our other function, which looks something like this. So Twilio now has that image URL, and it's going to do a GET request that's going to hit our other netlify function. This is just what the URL looks like. So you can see it's generate image, and then I'm passing over basically the username that you supplied in the email, in the text. And it's going to do kind of two things. It's going to go out and it's going to get information about your GitHub user. So it's going to hit the GitHub API, pull back your information. I'm only interested in your profile image because I thought, wouldn't it be cool to put your profile image into an image? Sure. And then it generates the image and it responds with the image. So whenever we respond with that serverless function, we are sending it a 200 OK, but we're setting the content type as image PNG, and we're writing the bytes out there, so it's like hitting an image directly. OK, so we've done two functions, and would you like to see some of the code? Yeah. Now, all this code is going to be available on my GitHub repo. It's going to be linked on the resource. Feel free to like play around with it, contact me about it. It's fine. So this is the code, which is very small. Let me bump it. Is that good? All right. Y'all in the back, you good? All right. So there's a lot of stuff going on here because I'm writing both Rust functions and JavaScript functions. And Netlify is going to take care of deploying both of them. My JavaScript functions are just simply in a Netlify functions folder. And so you can write these just like any JavaScript file. So the entry point here for the webhooks one is this webhooks Twilio.js. Like it's 27 lines of code. Not very big. And there's like some console logs in there too, because why not? So you can see we're using this with verified Twilio helper that I created, which basically just wraps the handler. It parses the body, because the body actually comes in not as JSON, because again, I guess if it ain't broke, I guess don't fix it. So we get that's how we're getting the body to where I can pull out what you sent in the text, and I'm just trimming it off. We're not doing a lot of like checking for errors because it's a demo. But then I'm just building a Twilio response. There's a nice package to help you with that. And so I'm setting the body, JavaScript function response, and the media with the URL of the image function and your username. And then we're just returning it. It's type XML. That's it. And then everything else is being done inside this generate image function. And this is a doozy. There's a lot of things going on. So how do you generate an image in JavaScript? This was an interesting thing to look at. There's been people who have created functions like this for doing the open graph images. So if you want to have custom open graph images for your blog posts, things like that, it's all based on that, where you can kind of pass in information and generate it. But what's happening is it is spinning up an instance of Playwright, which is loading a custom React component and then taking a screenshot of it. So we have a couple build processes making this work. There's a build process for making the function, but down here we have our image component, and this is like its own little project that it outputs just the React code that's been rendered. And so we're pulling that gets built, and it gets saved into a folder next to this file. It gets read in. So here's like all this web page that's building a little web page that's 1280 by 1280, and then Playwright takes a screenshot for us, and then we just return that out. So if it felt like it took a little bit for that to happen, that's why. That's how we do this in JavaScript. And so then we can move on. So those are the two functions in JavaScript. I can go into more detail if you like. Again, after this, I'm happy to talk to you about any of it. But let's look at how we did this in Rust. And what I do is I create a crates folder. The whole thing is a cargo workspace. So whenever I do, from the root, I do cargo build or whatever, whenever the release goes, it actually builds those two crates. And then I have in the make file here where, so it does all the different building stuff, and then it copies the binaries into the Netlify functions folder, because that's where Netlify needs them to deploy them. So inside this crate, inside crates, we have two crates. Each crate is its own function. Again, the easy one is the one for the Twilio webhooks. So if we look inside here in our main folder, we're using crypto. That's what's going to help us verify the signature. And we are using the Lambda runtime for the Lambda, some Certa for the JSON. But the handler is basically, let's grab the username from the body, and we're going to set the media URL, and then we're just going to respond with some TWIML. So same thing there. Basically the same code. We're returning an OK status code, et cetera, et cetera. This is kind of an interesting function, putting that together to pull out the to verify the signature and then also parse the body. But what we'll find is the generate image, this is actually, I think it's a little bit easier to kind of grope whenever you look at the code. So again, we are creating a Lambda function. So we have to build the handler. And so we are getting from the query string the username, because we're passing that on as a query string. I wrote a little function that grabs the GitHub user. And then what it does is it encodes that data. So I need to have that as binary image data. And then we can generate the image using this GitHub user. And so this is using a package called OG_writer. It's a fairly new package, but it works. Well, it works. I had to fork it and change some things, but that's kind of like the fun of it, right? So this works, and it works pretty fast. Here's the font that's being built into the binary. The avatar data, we're setting that data. We can do the border radius. You might, if you talk to each other after this, there are actually 3 different phrases that are added to your image, and so it's there's where it is there. I have a vector where I'm just randomly picking one, and yeah, and then it outputs that. And then what's really cool is you can actually write a test. So if you wanted to test this locally, instead of deploying it and going through all of your build minutes, which I've done, you can have it just generate the image so that way you can check and make sure everything's on. So that was a lot. That was the code. And do we have our numbers? Okay. So let's check our build. So our build has been published. That's the last thing I forgot to tell you. So we talked about being able to change these functions one by one. And to change them, all we need to do, because I'm using Netlify, is go into our Netlify TOML where I have my redirects. And so we're saying from webhooks Twilio, right now it's pointing to the webhooks Twilio RS, which is the Rust function. And then the /generate/image is pointing to the generate image RS function. And so whenever I want to switch those back and forth between which function is being called, it's just this redirect. So I can just uncomment one of these, comment the other ones, and redeploy, and then it's good. So you can change out only the function you want. So we've been deployed on Netlify. You can kind of see it there. Oh, it's much bigger up there. If you want, you can go ahead and text your username again, and this time it will respond using the Rust. And if you still have it in your mind of like how long it took for it to respond, then you might notice that it's faster. And while you're doing that, we can kind of look at the numbers. So we've got, on one side, we've got the Twilio webhook, and the other side, we've got the image generation. At the top, these are the numbers and the memory usage for the JavaScript functions, and then underneath it, it's the same thing, but for the Rust. And it's kind of interesting to see like the differences in it. So for the Twilio webhook, there's not a lot going on here. You know, we got 1.31, 1.66 for the Rust function, but for the JavaScript one, like it's not that bad. It's 2.15 milliseconds. Might not be worth it to like swap that one out. But if we take a look at the image generation, like look at these numbers. Like the execution time in JavaScript is like 10x what it is in Rust. So maybe that's the one that you want to target and be like, you know what, let's replace this functionality with a Rust function and speed up our performance, because we're probably, it's going to be negligible for the work on the Twilio webhook side. But like also look at the memory usage. And thinking about like how much you're paying for serverless functions, you're paying for like your memory usage, you're paying for your execution time, so that's going to include the cold start. And so, you know, I don't know what that's going to be in like actual real money, but I mean, that looks like a savings right there. So I hope this was interesting. I don't claim to be an expert on any of this, but I find it really fascinating. And the serverless functions was kind of my entry into learning Rust. Like I've been wanting to learn Rust for a while. I have a great community that's really big into learning it. And between this and then the WASM stuff, the WebAssembly stuff, got me into it. And so I've been like replacing my JavaScript functions with Rust ones, like kind of here and there. With my Twitch streams, like I have Twitch webhooks coming in, and they're now all using Rust. And so, I mean, it's gone from free to free, and but it's a fun exercise to do. I do want to give a special thanks to Chris Viscardi. They have helped me a lot getting these Rust functions to work. So I am a bit of a Rust novice. And they've always been really good to review my code and like suggest things. So I learned about the OG writer because of them, and they just launched Rust Adventure. So if you are interested in learning Rust, I highly recommend checking out this site. There's a free lesson that like comes to you over email, but they wrote it with like JavaScript and Python developers in mind. And they are an instructor on egghead.io. So if any of you are subscribers of that, you've probably seen their videos before. And they are part of the Party Corgi network. So that's what these wonderful little party GIFs are. And then here's that resources slide. So if you want to take a picture, I'm sure I can make these slides available somewhere too if you also want to like click on any of the links. And that's all I have for today. I thank you for attending. Like I know it's huge for us to be able to be all in the same room. It's really surreal, like seeing how spread apart the chairs are. But it was nice being able to like actually talk to people. And I'm happy to take any questions. If we run out of time, I'm going to be available at our booth downstairs. Yes. Yeah, so yes, exactly. Good point. Good point. So the question is, why did I choose Rust coming from a JavaScript background? Is that good? I have a computer science background, so I went to school and I learned Java and C and had to do all of that. And it's been many, many years since I've done any kind of like compiler language, right? Like everything is JavaScript. Like I started as a front end to JavaScript. When Node came around, I was like, I can do back end stuff now. I already know JavaScript. But I've wanted to get back into using like a compiled language. I've tried Go. At Cockroach, we use a lot of Go, but it just didn't feel right. And I tried Rust, and I'm really impressed with their tooling, with Cargo, with the compiler. The compiler is like my best friend because it's like, hey, you're trying to do this. I bet you wanted to do that. And I'm like, I did want to do that. And I'm just waiting for like Rust to get so smart that they'd be like, hey, friend, I fixed this for you. I got an idea of what you're trying to do, and I just wrote the code. But it's been a very nice experience learning. I also like that I like the Rust book. So if you go to rustlang.org, I think is the website, there is a free book that just like teaches you how to do it. It doesn't cover like the async stuff with like the futures, but I'm slowly getting into that too. But it's also nice to have a language that has a community around it, like a community of nice people. Like you can go with any question and no one's gonna be like, you dummy. Like they will like jump in and help you until you got it. So that's kind of what led me to Rust, is all of that. Any other questions? Yeah. That's a good question. And whenever so I showed the stats, and I'll go back to this page. So I showed the stats for the performance between JavaScript and Rust. And what they asked is what I thought it would be if I used Go. And that's a really good question. And the way I wrote this talk, like the CFP, is I could use like any combination of languages. It's just the demo is currently only written in this. So I would love to go through and write these functions again In Go, I would have tons of help. I could probably even just like ask some of our engineers to do it, but then I could, switch between that and see what their performance is like. So the reason that those numbers aren't up there is just it hasn't been written yet, but I fully intend to be able to have this as kind of like a demo where I can just swap between all of it. So we have two different functions that make up the whole demo, and then I could just say, I want this function to be JavaScript, I want this function to be Go, or I want this function to be Python. Like I could write a Lambda function using Python, and then we can just like improve upon it and take this around to different shows. Yeah. You'll write the Python? Excellent. Pull requests are welcome. Yeah, it's all open source. We're all community here. I do eventually get around to looking at the things that come up on GitHub. Like there's just numbers, lots of numbers. Yeah, the question was, did I put my GitHub repo up there? And yes, on this resources slide, the first one is the serverless talk demo repo. So most places on the internet, it's Aydrian. On GitHub, I'm Aydrian because that's my name and I got it first. And if you want to talk about like how bitter I am about not getting it for all the other places, I'll be downstairs. For the serverless demo, I am using the default GitHub license whenever you create a repo. I believe it's MIT. Yeah. Sweet. Well, thank you so much. I hope you have a great rest of the conference. I know there's not a lot left, but be safe getting home if you are having to fly or whatnot. I'm going to be heading back to New York because my corgi misses me. At least that's what I tell myself.